In this section of Chapter 11, we are going to build upon the concepts that we have already discussed, or tie them in more specifically. We're going to talk about stoichiometry, but in the context of aqueous reactions. And since we're dealing with aqueous reactions, we are going to tie in with the molarity concept that we already talked about. How do we do that? Typically, we are going to be given a volume of a reactant and a molarity of a reactant. And I can use both of those pieces of information to calculate the moles of the reactant. Remember that molarity is moles per liter. So if I'm given molarity and I'm given a volume, I can calculate moles. I can do that for both reactants. And once I have moles of the reactants, then I can use conversion factors to calculate moles of product. I can use those molar coefficients. And once I have the moles of my product, I can convert to the mass of the product using the molar mass of the particular product in question. Let's take a look at an example. If I am trying to determine how much chloride is in the water, I can do that by taking silver nitrate, which is a soluble compound, and adding it to my water that contains the chloride. When silver nitrate is put into water, it's going to split into silver ion and nitrate ion. The silver is going to find the chloride in the water and form the insoluble precipitate silver chloride, according to this reaction here. Nitrate, NO3-, is a spectator ion, so it doesn't appear on either side, or I can cross it out actually, because it doesn't take part in this net ionic equation here. Let's determine how much of a 0.25 molar solution of silver nitrate is necessary to precipitate all the chloride from 2 liters of water in which the chloride ion concentration is 0.0173 molar. Remember, this big M stands for 0.0173 moles over 1 liter. Now, what do I do with this information that I'm given? Well, I know that I'm given a volume and I'm given a molarity. I can use these two pieces here to calculate the moles of the chloride ion. Once I have the moles of the chloride ion, then I can use the balanced chemical reaction to find out how much silver I need to precipitate the chloride. And once I have the moles of silver ion, then I can use the moles and the molarity that is given to me to calculate the volume. Here's my reaction. And the first thing I need to do is find moles of the chloride ion in the solution of silver, or in the water, basically. So I have the volume of 2 liters, and I'm told that the concentration of the chloride is 0.0173 molar, or 0.0173 moles per 1 liter. And since I have 2 liters of that solution, I will have twice as many moles, so 2 times 0.0173 moles of chloride, giving me 0.0346 moles of chloride ions. Now that I have this amount in moles, I can go back up here and use molar ratios to convert to moles of silver. So find moles of silver ion that react with the chloride. Start with the amount you're given, 0.0346 moles of Cl- multiplied by, it's a 1-to-1 ratio, so 1 mole of silver plus for every 1 mole of chloride minus. Chloride will cancel, leaving me with moles of silver, which is 0.0346 moles of silver plus needed to precipitate this much chloride. Now that I have this amount, I can look back to the problem and it gives me the molarity of the silver nitrate solution. I don't focus, so don't get confused with the NO3. That's just a spectator ion, but the molarity of that solution, because it's a 1-to-1 ratio, will correspond to the molarity of silver ions as well. So once I have the moles and the molarity, I can use that to find the volume. Find the volume of silver solution that contains 0.0345 moles of silver. And here I am. I can take the moles, start with that, multiplied by my molarity, which is really I'm dividing by the molarity, but I'm writing it in form of a fraction where the liters are on top and the moles are at the bottom. So 0.250 moles are at the bottom, 1 liter is at the top. The moles will cancel and it will give me 0.138 liters of silver plus solution. I can leave it as liters because it didn't specify what units. Sometimes if you have to convert it to milliliters, you can multiply by 1,000 to give you 138 milliliters. But in this case, we can just leave it like that because it didn't specify any unit for the volume. Now let's look at part 2. Part 2 is pretty much the same. There's only one little difference. So determine how much 0.25 molar silver nitrate is necessary to precipitate all the chloride from 1.5 liters of solution that is 0.0435 molar in barium chloride. Okay, this is the molarity of barium chloride. But remember that 1 mole of barium chloride, this is barium chloride, will yield 2 moles of chloride ions. So if I start with 0.0435 moles of barium chloride, I will have twice as much chloride ions, okay, per every liter. However, I have 1.5 liters, so I have to take that into account. So the first thing that you need to do is to use this as a conversion factor to convert from moles of BaCl2 per liter to just moles of chloride minus per liter. And then use the same method that we did for part A. The only thing here is that in part A, we would have used 0.0435 moles per liter and then multiplied by this volume. Well, here you will have to use twice as much because 1 mole of barium chloride yield 2 moles of Cl minus. So don't forget to account for that when you figure out the total moles of chloride minus in the 1.5 liter solution. You have to take into account that you have twice as much chloride minus ions as you do barium chloride. Let's take a look at another type of problem. How much 0.150 molar NaOH is necessary to completely neutralize the acid in, we'll do ABC, 1.95 liters of a solution that is 0.225 molar in H2SO4. I'm going to do A for you, and then you can try B and C. Part A, I'm going to show you how the neutralization reaction works. B should be pretty easy because it's a 1-to-1 ratio. Then for 3, you can follow the same concept as up here, except you'll have a slightly different molar ratio there. But what do I have here? I have a base and an acid. So I have a neutralization reaction. If you don't remember, go back and review it. But my base is going to neutralize my acid, giving me a salt and water. Here is the balanced reaction for that. You will have to write these balanced reactions for the base and the acid in each case. And you're going to make sure they're balanced because that will affect your calculations. You have two NaOH molecules that react with H2SO4 to give you sodium sulfate and water. So this is my salt and this is my water. Okay, now I have given 1.95 liters of a solution that is 0.225 molar in H2SO4. I can calculate how many moles of H2SO4 I need, or I have in this solution, just like we did in the previous problem, and then use my balanced chemical reaction to go from moles of H2SO4 to moles of sodium hydroxide. Once I have the moles of that, I can use the molarity to calculate the volume. So let's take a look. I have my volume of H2SO4 solution, and I multiply that by 0.225 molar, which really is 0.225 moles of H2SO4 per 1 liter of solution. So my liters will cancel, and I multiply those two to get 0.4388 moles of H2SO4. Now that I have the moles of my acid, I can back calculate, or I can calculate the moles of my base using their molar ratio from this equation. Here it is. I start with the moles of my acid, which is 0.4388 moles. Then I want moles of base on top and moles of acid at the bottom because I want the moles of acid to cancel. So times 2 moles of NaOH, because NaOH has a 2 in front of it, per every, for 1 mole, because this is 1, even though it's not written, 1 mole of H2SO4. H2SO4, so moles of H2SO4 cancels, and what I have left is 0.4388 times 2 divided by 1 to give me 0.877 moles of NaOH. Now that I have the moles of NaOH, I can use the molarity to convert to volume. Here it is, 0.8776 moles of NaOH multiplied by my molarity conversion factor, which in this case I write the volume on top because that's what I want to end up with, and the moles at the bottom. So 0.15 molar is written as 0.15 moles of NaOH for every 1 liter. My moles will cancel, and I would take 0.8776 times 1 divided by 0.15 to give me 5.85 liters of NaOH. So to neutralize completely 1.95 liters of the solution that is 0.225 molar in H2SO4, I would need 5.85 liters of a 0.15 molar NaOH solution. Now I'll give you some time to work on part B and C. The last problem we're going to look at is this one. This is a little more involved, but I wanted to show you anyway. The vitamin C, so ascorbic acid content of Gatorade and other sports drinks, can be measured with triiodide ion, so I3 minus. This is the reaction that occurs, so I3 minus plus vitamin C, giving me 3I minus plus C6H6O6 plus 2H plus ions. Determine the mass of vitamin C in milligrams that is contained in a 350 milliliter bottle of Gatorade if a sample of 25 milliliters requires 29.25 milliliters of 0.00125 molar I3 minus solution to react with all of that vitamin C. So here's how I go about it. Here's my reaction. The first step is to find the moles of I3 in the solution. I'm given the volume and the molarity of I3-. So I take the volume and I multiply it by the molarity. So 0.0295 liters. Make sure these are converted to liters because molarity is moles per liter. So liters have to match. The units have to match. You cannot use milliliters here. Just divide. So to convert from milliliters to liters, divide by 1,000. And that's what we've done here, which is moved the decimal point 3 times to the left. Then I take 0.09 or 0.2925 liters times 0.00125 moles per liter. And looking at the equation here, I have 1 mole of I3- for every 1 mole of vitamin C. This first step gives me the moles of I3-. This step here converts it to 2 moles of vitamin C. So I have 1 mole of vitamin C for every 1 mole of I3-, which will cancel, leaving me with 3.656 times 10 to the -5th moles of vitamin C. Now that I have the moles of vitamin C, I can, which I already found, I can then convert that to the mass of vitamin C by using the molar mass of vitamin C. Okay, so 3.656 times 10 to the -5 moles, which is what I have here, multiplied by the molar mass of vitamin C, which is 176.1 grams per 1 mole, cancel moles, giving me 6.44 times 10 to the -3 grams of vitamin C. That is the mass in grams. Now, that is the mass in grams in 25 milliliters. What about 350 milliliters? What is the total mass? So I take 6.44 times 3 grams of vitamin C in 25 milliliters times the total volume of 350 milliliters. The milliliters cancel, leaving me with grams, but it asked in milligrams, so I multiply by 1,000 milligrams per gram. My grams will cancel, leaving my answer in milligrams. So I will take 6.44 times 10 to the -3, multiplied by 350, multiplied by 1,000, divided by 25, giving me 90.2 milligrams. So this is the mass in milligrams of vitamin C that is contained in 350 milliliters of Gatorade.